The learning objectives for this session are to recognize and solve direct and joint problems, and to recognize and solve inverse and combined variation problems. What is direct variation? A direct variation can be expressed in the form y equals kx. In this equation, k is called the constant of variation. To express a direct variation, we can say that y varies directly as x. In other words, as x increases, y increases or decreases at a constant rate. Let's have a look at the key concept of direct variation. Y varies directly as x if there is some non-zero constant k such that y equals kx. K is called the constant of variation. For example, if y equals 3x and x equals 7, then y equals 3 times 7 or 21. If you know that y varies directly as x and one set of values, you can use a proportion to find the other set of corresponding values. If y1 equals k x1, we can solve for k, which gives us y1 over x1 equals to k. And similarly, if y2 equals k x2, solving for k gives us y2 over x2, that equals to k. Therefore, we can say y1 over x1 is equal to y2 over x2. Using the properties of equality, you can find many other proportions that relate the same x and y values. Example 1. If y varies directly as x and y equals 15 when x is equal to -5, find y when x is equal to 7. Use a proportion that relates the values. So we already know that y1 over x1 equals y2 over x2. This is direct variation formula. y1 is 15, x1 will be -5. This was provided to us at the start of the question. Now we have to find y, which will be y2 when x equals 7. So therefore x2 will equal to 7. y1 is 15, x1 is -5, and x2 equals 7. We can use cross multiplication, so we'll have 15 times 7 on the left hand side and -5 times y2 on the right hand side. We are cross multiplying. In order to find the value of y2, we are going to divide 105, which is on the left hand side, by -5. So if you divide both sides by -5 and simplify, we will obtain the value for y2, which is -21. We have divided each side by -5 to obtain -21. Try this question 1. If r varies directly as t and r equals -20 when t equals 4, find r when t equals -6. Please attempt this question and play this clip again when you are ready. If you do need more help, you can watch example 1 again. It's time to share the solution for try this question number 1. The answer to this question is as follows. Please have a look through the solution. If you do need more help, please look at example number 1 and you can attempt this question again. What is joint variation? Another type of variation is joint variation. Joint variation occurs when one quantity varies directly as the product of two or more other quantities. Let's look at the key concept of joint variation. Y varies jointly as x and z if there is some non-zero constant k such that y equals k x z. Example, if y equals 5xz, x is equal to 6 and z is equal to -2, then y equals 5 times 6 times -2 or -60. If you know that y varies jointly as x and z and one set of values, you can use a proportion to find the other set of corresponding values. If y1 equals k x1 z1, then k would equal to y1 over x1 z1. And similarly, if y2 equals k x2 z2, then k would equal to y2 over x2 z2. Now that we have k as the subject, we can say that y1 over x1 z1 equals y2 over x2 z2. Example 2. Suppose y varies jointly as x and z. Find y when x is equal to 9 and z is equal to 2 if y equals 20, when z equals 3 and x equals 5. Firstly, we will use a proportion that relates the values. So we have y1 over x1 z1, which equals to y2 over x2 z2. We will substitute the values now. So y1 equals 20, x1 equals 5, and z1 equals 3, because we are told in the question if y equals 20 when z equals 3 and x equals 5. Now values for x2 and z2 are going to be 9 and 2 respectively, because we have to find y when x is 9 and z is 2. So we have substituted those values here. Now we're going to cross multiply. So 20 will multiply by 9 times 2, and then y2 will multiply by 5 and 3. This is the concept of cross multiplication. Now as we simplify, this gives us 360 equals 15y2. In order to work out the value of y2, we will divide both sides by 15, and this gives us the value of y2 as 24. Try this question 2. Suppose r varies jointly as v and t. Find r when v equals 2 and t equals 8. If r equals 70, then v equals 10 and t equals 4. Please attempt this question. When you have completed this question, you can play this clip again to view the solution. Welcome back. I hope you've had an attempt at try this question number 2. It's time to share the solution with you. Please carefully study the solution. The answer is R2 equals 28. If you are still unsure and would like more guidance, Please watch example number 2 and you can try this question again.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Recognize and solve inverse and combined problems. What is inverse variation? Another type of variation is inverse variation. If two quantities show x and y show inverse variation, their product is equal to a constant k. Inverse variation is often described as one quantity increasing while the other quantity is decreasing. For example, speed and time for a fixed distance vary inversely with each other. The faster you travel, the less time it takes to get you there. Inverse variation key concept. Y varies inversely as x if there is some non-zero constant k such that xy equals k or y equals k over x, where x is not equal to 0 and y is not equal to 0. Example, if x times y equals 2 and x equals to 6, then y would equal to 2 over 6 or 1 over 3. Example 3. If a varies inversely as b and a equals 28 when b equals negative 2, find a when b equals negative 10. Use a proportion that relates the values. a1 over b2 equals a2 over b1. That's the inverse variation. We are going to substitute the following values. a1 equals 28 and b1 equals negative 2. b2 will equal negative 10. After substitution, we are going to use cross multiplication. So 28 will multiply with negative 2. And negative 10 will multiply with a2 using the technique of cross multiplication. If we simplify this, this gives us negative 56 equals negative 10 a2. If you divide each side by negative 10, a2 will equal to 5 and 3/5. Try this question 3. If x varies inversely as y and x equals 24 when y equals 4, find x when y equals 12. After you have attempted this question, you can play this clip again. If you need more help, you can watch example 3 to get more guidance. It is time to share the solution for the question. Try this question 3. Here is the solution. Just a reminder that the formula which you will use is x1 over y2 equals x2 over y1, and the final answer is x2 equals 8. Please study the solution. If you need more help, watch example 3 again to help you with this question. What is combined variation? This is the final type of variation which we will study. Another type of variation is combined variation. Combined variation occurs when one quantity varies directly and or inversely as two or more other quantities. If you know that y varies directly as x, y varies inversely as z, and one set of values, you can use a proportion to find the other set of corresponding values. If y1 equals to k x1 over z1, that tells me that k will equal to y1 z1 divided by x1. And on the right hand side, y2 equals k x2 over z2, so k will equal to y2 times z2 divided by x2. So therefore we can conclude, as k is the subject, that y1 z1 over x1 equals y2 z2 over x2. Example 4. Suppose f varies directly as g and f varies inversely as h. Find g when f equals 18 and h equals -3 if g equals 24 when h equals 2 and f equals 6. First, set up a correct proportion for the information given. f1 equals kg1 over h1 and f2 equals kg2 over h2. This is because g varies directly as f, so g goes in the numerator. H varies inversely as f, so h goes in the denominator. So g1 and g2 in the numerator, h1 and h2 in the denominator. Now we will solve for k, and this gives us k equals to f1 h1 over g1 and k equals f2 h2 over g2. Now we will set the two proportions equal to each other. So f1 h1 over g1 equals f2 h2 over g2. Now we can substitute these values. f1 equals 6, g1 equals 24, h1 equals 2, f2 equals 18, and h2 equals -3. Now we will solve for g2. In order to do that, we will cross multiply. So 24 times 18 times -3 equals 6 times 2 times g2. Simplifying this further will give us -1296 equals 12g2. We will divide both sides by 12, and this gives us the answer of g2 equals -108. So when f equals 18 and h equals -3, the value of g is -108. Try this question 4. When you have attempted this question, you can play the clip again. Here is the solution to try this question 4. First of all, you would use the information to set up the correct proportions. Then you would solve for k. Then you would substitute the correct values. After substitution, you would cross multiply and simplify, like you've seen in example 4, to work out the value of t2 in this case, which is -80. If you need more help, please watch example 4 again.